Hello everyone, welcome to my class. In today's class we are starting chapter 9, Analytic Geometry, and in today's class I am going to cover the circle and the ellipse. So let me start the class right away. First let me give you a quick introduction of analytic geometry. Analytic geometry is a branch of mathematics where one studies geometric shapes by using tools of algebra and a coordinate system. In this chapter 9, we explore the geometric shapes formed when a right circular cone is intersected by a plane. We investigate 4 sections of the cone by a plane, called the conic sections, such as circle, ellipse, hyperbola, and parabola. The angle at which the plane intersects the cone determines the shape of a conic section. Note, if the plane goes through the vertex of the cone, the resulting section is a point, or a line, or 2 intersecting lines. By the way, we focus the non-degenerate conics, that is, we focus circle, ellipse, hyperbola, and parabola in this class. So now let me visualize the conic sections here. So if the plane cuts the one nape of the cone horizontally, then the cross section is a circle. If the plane, in the second diagram, if the plane cuts the one nape of the cone kind of diagonally here, then the cross section is a ellipse. In the third diagram, if the plane is parallel to the edge of the cone and it cuts the one nape of the cone, then the cross section is a parabola. In the fourth diagram, if the plane cuts both napes of the cone, then the cross sections are the hyperbolas. Now let me give you the degenerate conics also. If the plane cuts the cone at a vertex, then the cross section is either a point or a line or a pair of intersecting lines. But in this class we only focus on circle, ellipse, parabola, and hyperbola. So next, quick side note, each conic sections can be described by a set of points in the plane. Since all of these conic sections are the 2 dimensions geometric figures, so we describe using the order pair in the plane. And the conic section is defined in terms of the distance between points in the plane or the distance between a point and a line. In general, the graph of a quadratic equations in 2 variables x and y, such as ax square plus bxy plus cy square plus dx plus ey plus f equals to 0, where a, b, c, d, e, f are constant, here the coefficients, represents a conic. So now let's begin sections 9.2, the circle and the ellipse. First, the definition of circle. A circle is the set of all points in a plane that are an equal distance. The equal distance is called the radius of the circle. From a given point, the point is called the center. So here, center is, let's say, hk, and the equal distance of this graph from the center is r. If the distance is r, then the equation of the circle center at hk and radius r is given by here, the binomial x minus h square plus the binomial y minus k square equals to r square. Since r square not 0, we can divide both sides by r square in the next line here. Then we have these equations, x minus h square over r square plus y minus k square over r square equals to 1. This is the equation of circle in standard form. Similarly, if the center hk of the circle is at origin, then put h equals to 0, k equals to 0, then the equation of circle reduces to simply x square plus y square equals to r square. Equivalently, this is same as x square over r square plus y square over r square equals to 1. Awesome. I hope this makes sense to you all. Now next, let's talk about ellipse. So here, let me point one thing. So here, I put different color for this r. So this r is this is the distance of the graph from the center, horizontal distance. I put this color here, and I put this gray color here. The r, this r is the distance, this is the vertical distance of the graph from the center. So here, both distances are equal. But the questions we can ask to ourselves, what happens when these distances are unequal, not the same? Then we will get the ellipse. So next, so here I put this distance is a and this distance is b, center is hk, then it forms a ellipse. So now the definition of ellipse: an ellipse is the set of all points in the plane such that the sum of their distances from two fixed points, those fixed points are called foci here. So the equation of an ellipse with center hk is just compared to the equation of circle here, x minus h square, here x minus h square over, since our distance, that means the horizontal distance of the graph from the center and vertical distance of the graph from the center are equal, means circle, unequal means the ellipse here. So the equation of ellipse is x minus h outside square over a square, if that's better, plus y minus k outside square over b square equals to 1. If these two distances are unequal, then this forms an ellipse, and this is the equation of ellipse. Next, the equation of an ellipse with center at origin, put h equals to 0, k equals to 0, then this becomes x square or a square plus y square over b square equals to 1. By the way, if these a and b are equal, then this equation reduces to a equation of circle. That means ellipse reduces to a circle. I hope this makes sense to you all. Now let's move on. Some more comment here. If a not equals to b, where a is a horizontal distance from the center to the graph and b is the vertical distance from center to the graph, means this is the a distance, this is the b distance. The longer axis is called the major axis and the shorter axis is called the minor axis of the ellipse. So here, this side is longer, so now this is the major axis, and this side is shorter, so now this side is called minor axis in the ellipse. The foci lie on the major axis, and the endpoints of the major axis are called the vertices of the ellipse. So now let me visualize the key feature of the ellipse here. So here, so in the first diagram here, this is the longer axis, so this is the major axis. The endpoint of the major axis are the vertices, so here is the h0 and minus h0 are the coordinate of vertices, and focus lies in the major axis, so the coordinate of focus are c0 and minus c0, and this side is a shorter axis, which is the minor axis. In the next diagram, and it's a vertical ellipse now here, so the major axis is this vertical axis, this horizontal axis is the minor axis, focus lies in the major axis, and so on. Now, quick notes: if the point with coordinate a, 0 is a vertex and plus minus c0 are foci, then the sum of the distances from the foci to the vertex is 2 times a, which is the length of the major axis. So this length is 2a, which is the length of the major axis. 2. Foci formula is b square plus c square equals to a square. Third, in general, the second degree equations in x and y, this equations represents an ellipse if b equals to 0 and a not equals to c. I'm talking these are the coefficients respectively here. And similarly, the second degree equation in x and y represents a circle if b equals to 0 and a equals to c, where b is the coefficient of xy, a is the coefficient of x square, and c is the coefficient of y square respectively in these equations. Quick example here. 9x square plus 16y square equals to 144. This is an equation of ellipse, whereas 9x square plus 9y square equals to 144, that's an equation of circle. I hope it makes sense to you all. So now let's do some example. Example 1. Find the equation of a circle with a center at point P with coordinate 2, 3 and radius r equals to 4. So then let's begin the solution. Just apply the formula. So the equation of circle with center h, k and radius r is by formula x minus h outside square plus y minus k outside square equals r square. So here by that formula it turns out that x minus 2 outside square plus y minus 3 outside square equals to radius, which is 4 square. Then let's FOIL this here in the next step. So x minus 2 outside square becomes x square minus 4x plus 4. Similarly, the plus as it is, y minus 3 square becomes y square minus 6y plus 9. This equals to, on our right hand side, 4 square is 16. Great. So let me scroll down. Oh, this is the same line here. So here. Then the last line here, I just rearrange the term here. So x square as it is, minus 4x as it is, y square as it is, minus 6y as it is. So now here, let's simplify the constant term. So 4 plus 9 is 13. And take the 13 to the right side, it becomes minus 13. 16 minus 13 is 3. So we found the equation of circle with given informations. Great. So now let's move on. Let's do example 2. So that the second degree equation in x and y, which is x square plus y square plus 4x minus 6y equals 12, represents a circle and find its center and radius. So let's begin the solutions. So the idea is we need to rewrite these equations using completing the square in the form of x minus h outside square plus y minus k outside square equals to r square. Then we can compare that equations to the equation of circle. Then h and k gives us the coordinate of center and r gives us the radius. So by completing the square, so let's put the x terms here. So x square plus 4x plus the magic term here. Then plus, I'll come to that magic term later. Let me finish this line first. Then let's collect the y terms here. So y square minus 6y and add the magic term here. Then collect the constant to the one inside. So we have 12 is a constant on our right side. Then in that magic term, so in the completing the square method, that magic term equals to, so that magic term equals to divide the coefficient of x by 2. So here the coefficient of x is 4, divide by 2 is 4 divided by 2, which is 2, then is square, and put that terms here. So we add the 4 here. We add the 4 one inside, so we have to add the 4 in other hand side so that it will be the balanced equation. So we add 4 here on our right hand side as well. Similarly, for this y terms here, this magic term equals to divide the coefficient of y by 2 and square and add here and add here. So here coefficient of y is minus 6 divide by 2 minus 3 square 9. So 9 here, 9 here. I hope this idea makes sense to you all. And by the way, the right hand side, 12 plus 4 plus 9 turns out to be 25. Then in the next line, since this 3 terms becomes this binomial is square, x square plus 4x plus 4 is x plus 2 outside is square. Similarly, y square minus 6y plus 9 becomes this binomial y minus 3 is square, equals to 25 is 5 square. Hence, comparing these last equations to the equation of circle, x minus h square plus y minus k square equals to r square, we got the center of the circle is here, minus 2, 3, and radius simply 5. And just to visualize, it is here. The center is, here is a minus 2 and 3, and radius is this distance here. So from here to here is 3, and then here to here is 2. So 2 plus 3 is 5. So radius is 5. I hope this makes sense to you all. Now let's move on. Let's do example 3. Identify the given equations. The given equation is 9x square plus 16y square equals to 144. Is that of an ellipse or a circle? Find its key features. So let's begin the solutions. Let's rewrite the given equation in a standard form. Divide both sides by 144, then it reduces to x square over 16 plus y square over 9 equals to 1. So when you divide both sides by 144, then cancel the 9 and 144, which is 16 times. In the second term here, cancel 16 and 144, which is simply 9. And on the right hand side is 1. And it's an horizontal ellipse because the x square over a square is 4 plus y square over b square, b is 3. Since a is bigger than 3, so this is a horizontal ellipse, which is this one here, by the way. So its center is origin from this equation here, and a is 4, b is 3. So hence, vertices are by formula plus minus a comma 0, which is 4, 0 and minus 4, 0. So these are the vertices. Similarly, endpoints of the minor axis are 0, positive b and 0, negative b. So b is 3, so 0, 3, 0, minus 3. So this part is clear. The length of major axis is 2 times a, since a is 4, so major axis length is 8. And length of minor axis is 2 times b, since b is 3, so minor axis length is 6. For the foci, we use this formula. C square equals to a square minus b square. Let me show you the formula there. So here we are using, to find the foci, we are using this formula here. B square equals to a square minus c square. So let me scroll down here. So then here c square equals to a square minus b square. Since a is 4, b is 3, so then c square turns out to be 7, hence c equals to radical 7. Hence c equals to radical 7. Awesome. So the foci are plus c comma 0 and minus c comma 0. Since c is radical 7, so the coordinate of foci are here, radical 7 comma 0 and minus radical 7 comma 0. So now let me visualize all these informations here. So which is here now. So this is the major axis. This is the major axis. Length is here 8. This is the minor axis. Length is 6. And the vertices are here, this point and this point. These are the endpoints of the major axis. And foci are here and here. I hope this makes sense to you all. Now let's move on. Now let's do example 4. Identify the given equations. The given equation is 4 times x minus 1 outside is square plus 9 times y minus 4 outside is square equals to 36. As an ellipse or a circle, find its key features. Begin the solutions. So begin the solutions. Rewrite the given equation in standard form. So let's make right hand side 1. Divide both sides by 36. Then we have x minus 1 outside is square over 9 plus y minus 4 outside is square over 4 equals 1. So here, by the way, we divide both sides by 36. 4 cancel 36 9 times, 9 cancel 36 4 times, and 36 cancel 36 1 time. It is an horizontal ellipse where here A is 3, B is 2. And from these equations, center is 1, 4, A is 3, and B is 2. Now to find the vertices, since the vertices are the endpoints of the major axis, so the center, in the x-coordinate of the center, we need to add the value of A and subtract the value of A respectively. So we will get the vertices 4, 4 and negative 2, 4. I hope this makes sense to you all. Similarly, endpoints of the minor axes are 1, 6 and 1, 2. Similarly, length of the major axis is 2A, which turns out to be 6, and the length of minor axis is 2B, which turns out to be 4. To find the foci, we use the formula c square equals to a square minus b square. Simplify gives us c equals to radical 5. Hence, the foci are located at the horizontal distance of radical 5 units from the center, which is at 3.2, 4 and negative 1.2, 4. So now let me visualize all of these informations in the diagram. So here, this is the major axis, this is the minor axis, these are the vertices, and these are the foci, and this is the center. So center is from here, 1, 4, here. I hope this makes sense to you all. Great. Next, let's do example 5. Find the equation of an ellipse with given informations. Vertices are at plus minus 8, 0 and foci are at plus minus 5, 0. By the way, comparing vertices to plus minus a, 0, a turns out to be 8, and the comparing foci to plus minus c, 0, c turns out to be 5. So which is here, a is 8, c is 5, and center is origin. Then let's find the value of b. So by the formula, b square equals a square minus c square. Then next step, b square equals to a is 8, so a square is 80 square, minus since c is 5, so c square is 5 square. 80 square is 64, minus 5 square is 25. 64 minus 25 is 39. So now the equation of ellipse is in standard form. This is the formula, x square over a square plus y square over b square equals 1. So we have the value of a square is 64, b square is 39. So let's put here. So in the last line, x square over 64 plus y square over 39 equals 1. This is the equation of ellipse with these given informations. Great. So now, last but not least, quick remark. The eccentricity, which you denote by E, of an ellipse is a measure of how elongated the ellipse is, where E lies strictly between 0 and 1. Great. So with that remark, we finish these sections. Thank you.